All right, good morning, good afternoon, everyone. Welcome to yet another Code Presents. Today about the advances and challenges in generative AI for image generation. My name is Otto Dobretsberger. I'm a senior software dev at Code Consulting, and I will be walking through this session today with you. For those of you who are new, we are the Code Group. We're helping people build better software. We're comprised of Code Consulting, Code Magazine, Code Training, and as of recently also Code Staffing. A little bit about me. Like I said, my name is Otto Dobretsberger. I'm a senior software developer at Code. I've been here for a little bit over 15 years altogether. I got some degrees in biomedical science and some advanced degrees in computer science. I've been a professor at the University of Houston for just over 10 years now. Author, speaker, presenter. In fact, I have another 2 conferences later this year I'll be presenting at. One of them will be Microsoft.NET conference, and the other one will be the Dev Intersection. My spare time, if I'm not writing code, I like to pick up heavy things and put them back down. I'm a 2-time world record holder in bench press. Yeah, if I don't write code, that's what I do in my free time. If you have any questions, here's my email address. Feel free to email me. Certainly get an answer back. Before we get started, just a few slides about what we are, who we are, what we do. We're at Code Consulting. We are, like I said, we help people build better software. We write custom software. We focus, as of recently, specifically on artificial intelligence, co-pilot development, that sort of stuff. We also provide application security testing. We, of course, do all kinds of user interface and interaction designs. One of our strengths is project rescue. One of our other strengths is legacy conversion projects. And of course, we also support and maintain existing applications. Some of our previous and current customers you can see on the slide. The AI consulting services, we have a new offer called the Executive Briefing. If you're interested in that, go to codemag.com/executive briefing. We can help you with your AI needs. We can check out what does AI mean for you, for your business specifically, and how we can help you separate yourself from the competition to gain a competitive advantage in whatever industry you are in. We're very flexible in that sense. I mentioned Code Staffing. If you're interested, can help us disrupt the world of staffing. We are supplying customers with highly trained, highly capable staffing people for their respective needs, whatever they're looking for. And of course, we're also making a leap forward in that industry by giving our people that we have on staffing industry-leading benefits. So it's a win-win for everyone in that situation. In that sense, we're currently hiring on all cylinders in that regard. If you are interested, codestaffing.com/careers would be the place to go and check that out. We have some upcoming events from Code Training, Code State of .NET, and Code Presents. We have the State of .NET about .NET 8, November 15th. And we have another Code Presents October 25th coming up about large language models run locally. Tune in if you're interested in that. The links are on the slides. You can get a free subscription to our magazine. Follow this link for those of you who don't have one just yet. We also have a Code Focus issue that always centers around very specific topics, not just general issues like most of our other issues are. If you don't have one yet, just follow the link and get yourself a free subscription from Code Magazine. And like every Code Presents, we are doing a survey with a $100 Amazon gift card to win. The survey must be completed by Friday, October 6th to be eligible for it. You can either follow this link or you can scan one of those QR codes. And since this is a presentation about generative AI, I decided to try out one of those generative AI software tools to create an QR code that doesn't look like the general, well-known style of QR code. So the right one, you can see that's what you expect from a QR code. The left one has a style of the universe with planets, stars, and so on. And it depends on your camera. It depends on the software reading the QR. I've tried it with 2 phones. One phone picked it up with no problem. The other phone did not pick it up at all. That's why I have the regular QR code here as well, so you can try it yourself if your phone is capable of picking this up. It just depends. There's so many settings, as we'll see throughout this presentation, that somebody can work with, that software depends on, that everything literally depends on the result and what comes out at the end. Sometimes it's just not there yet. And yeah, like I said, this QR code with the universe thing, with the stars and the planets, works for some, probably won't work for others. We have new attendees, we have repeat attendees. Regardless, thank you for attending to begin with. Based on the sign-up list that I looked at, I assume we have a good mix of developers, decision makers, regular users, non-technical people who are just interested in it. So I'm trying to make this interesting for everyone. I'm going to try to make this understandable for everyone so that everyone walks out of this with some new knowledge, some interesting thoughts, and something to look forward to when they dive into AI and look certain things up on their own. What is the agenda for today? We're going to start with some introduction. I'm going to go through generative AI, its importance. We're going to contextualize it, understand in what context AI generation and image generation specific is important, what ups and downs it has, what it comes with, what the goal of this presentation is. We're going to take a brief dive into the history of and the evolution of generative models. We're going to look at how it really became a thing. We're going to see that it's not something that just came up this year, even though it really skyrocketed this year with the advancements. But this is all not something new, right? This image generation and all the technology, the algorithms and all that behind it has been around for years. Some of this stuff for decades. It's just all of these components that make up such a generative AI platform that we are used to by all the different online platforms that we can use. In order for this to come together, all these components just had to mature. And when I mean all of them, I mean one of these platforms that we all know to generate AI images isn't just composed of one algorithm, right? It's always, as we'll see, a conglomerate of several different moving parts that all have to play together. And just because one has been developed and has matured to an extent where it's stalling doesn't mean that's it, right? All the other parts still have to be developed and so on as well. So we have to understand that. We're going to look at GANs and VAEs in particular, the Generative Adversarial Networks and Variational Autoencoders. Look a little bit closer at those two, how they differ, what they are. We're going to look at what it takes to run a simple generative model, what it takes to prepare the environment, prepare some data. We're going to what it takes to train some of this data, and we're going to discuss some of the parameters that influence the outcomes. Of course, we cannot focus in and deep dive in any of this to a specific on a specific level, because that would totally go beyond the time limit that we have for this presentation. But we're going to take a good overview of everything that I've mentioned so far. We're going to look at a demonstration, what images can be created with various platforms, what parameters can be set. We're going to look at the distinction between running something local versus running something on a platform that is scalable, that has virtually unlimited resources to run it. And we're going to discuss the limitations and capabilities of it. We're going to see, okay, what are certain things to consider financially, ethically, what is future trends, what do we have to be aware of, what is or where is this journey really taking us. What is the importance of generative AI image generation? First of all, that really plays into where do we need it and how can we make use of it and where do we really benefit from it. And there's various different industries where we already see a major leap in advancements, where we can already see that a lot of things are going to be or are already being replaced by generative AI image generation. Think about art, for instance. Think about digital art. Think about simulation. Think about architectural applications. Think about stuff where we used to have a team of artists designing things, first sketching things out, coming back with sketches, then fleshing things out and making it more realistic, making it to a point where we can say, okay, we want to work with this, and that process spans out and goes on for weeks. Versus using generative AI, we can do that and more, given that we have the hardware, the power to drive this within a few minutes, right? We do not have to have this time delay anymore for waiting for concepts, waiting for sketches, waiting for art, for all different kinds of applications, for the architect industry, for fashion industry, for especially video game industry, right? There were teams of artists writing functionality to create textures, to create sprites, to create art for all different kinds of things video games need, which is a long process. And now we can do that and more with a fraction of the time frame, and advance our entire development by magnitudes, essentially. We have to understand that all of this has to be contextualized, which means we have to understand the role, the scope, and the limitation of it. Right? It's all not just fun and games and all that. There's a lot of drawbacks and a lot of things to consider as well. Legally, there's a lot of things to consider ethically. So there's a lot of stuff that, a lot of unanswered questions to some degree that we have to continue to ask and try to find solutions for. And well, we have to also make sure we understand how it has evolved so far, what is the expectation for the future, and where do we expect this to go in order to prepare for it. The historic evolution, if we look at generative AI, like I said, it's not something new, right? There have been early efforts for it. RBMs have been around for a very long time, restricted Boltzmann machines. There are some, if you look at that image to the right, some examples of where years and years and years ago, generative AI has been used to create or try to create faces, especially for humans, right? Different categories, different genders, different ages. Generative AI, especially RBMs, have been used to try to create this. And it was more or less an effort that did not really go to anything as hyper-realistic as we are looking at as of recent, right? This year especially, this just has taken off to the point where, yes, we are able to create almost photorealistic images of people that in reality do not exist, that the AI created all on its own. We're going to look at GANs and VAEs. I'm not going to get into them on this slide too much because I have separate slides for those. Also on the improvements of GANs, of course. Flow-based models have been around forever as well. Flow-based models, early stages, also have been used to start, and we'll see some examples of early stages and what I mean with that later in my presentation, where I can say, okay, this is not something new, this image generation with giving a prompt and receiving an image to a certain degree. I would have been able to do that 3, 4, 5 years ago, right? It's just not on the level as we have it today. And the biggest difference in there, we're going to take a look at, especially the hardware side of it, what makes it so different now that it has been in the past, and why it is such a hype now. We have benchmarks, right? We have to look at how do we benchmark these artificial intelligence image generative models. Is it something that people benchmark? Is it something that we can quantitatively or qualitatively automatically benchmark? Is it something that we have certain algorithms for or assign certain scores for, right? There is something called inception scores, there's differential inception distances, FIDs, there is precision recall scores, PRs. They are algorithms that run alongside image generation and provide certain scoring metrics in order for us as humans to then analyze and say, okay, this one is better at this other one is better at that. Using these quantitative and qualitative scoring mechanisms, we can automatically get a little bit better an overview of how we can fine-tune our algorithms and how we can make sure that whatever changes we make, we're going into the right direction and not backwards. Of course, the driving competition also has helped in the evolution forward. As soon as something becomes more, let's say, mainstream, more available to the general public, more and more people, more and more companies, more and more organizations jump onto this new technology and try to be, of course, better than anybody else. That is some healthy competition, right? And people start trying to outdo each other. They say, hey, we have the better one. No, we have the better one. And that, of course, recently, with the advances in technology that allow people to not rely on, hey, I need a super beefy computer or supercomputer in the cloud to run this, but I can actually run something decent on a local computer that an average consumer can buy, of course, gives this whole industry a much better and more healthier competition. With the advancements of also the user-driven and community-driven benchmarking, that furthers that even more, especially when it comes to open source, right? Not everything in AI is closed source. There's a lot of open source models out there, and they, of course, drive the competition amongst each other, but also influence the closed source competition, because why would anybody try to pay for services for closed source service providers if they can do something similar or sometimes even better with open source products? We have to look at ethical considerations that really have become a thing in the history and evolution of this whole generative AI thing, because if we look at what was able or what AI was capable 3, 4, 5 years ago, some of these ethical considerations just weren't a thing, right? If there was something where you try to recreate the realistic image of a person, right, in a certain scenario, in a certain place or something, if that was done 5 years ago, anybody would have said, yeah, that's fake, right? That is not real. AI wasn't capable of placing a celebrity at a certain place and say, yeah, that person was there. Nowadays, yeah, not so unlikely anymore, right? With photorealistic AI, I can say, put a certain person at a certain place, generate me the background for it, make it as realistic as possible. And if that is actually a model that is capable of doing it, which nowadays we do have, we have to think about, hey, is this real? Is this not real? Is this a deep fake? Is this not a deep fake? Is this something we have to somehow regulate or not? Speaking of regulation, there's a lot of other unanswered questions as well. Copyright questions, use of training data, for instance, right? Is anybody allowed to use whatever data is available online, or is anybody allowed to use any data they actually do pay for as well for training their own models? Just because I, for instance, get myself a subscription to Shutterstock, am I therefore allowed to use all their images to train my models and then use that information to create my own images and directly compete with Shutterstock with my own images? Questions that weren't a thing years ago, but now are a thing, right? All these questions need to be answered. Of course, there's also a lot more severe and important questions in the ethics department to answer as well, right? There's people who can produce harmful content, people can produce censored content, people can produce content that's taboo in certain countries, for certain people. So all of these kind of things that are regulated even on a government level for certain countries. Hey, you're not allowed to produce images like this or like that in this country, but in other countries you are. Who regulates that? And who checks where you are and what you do? So a lot of unanswered questions in that regard that need to be taken in consideration. Recent advances have been made, especially on GANs and VAEs, but GANs and VAEs aren't new. GANs and VAEs have been around for a while, and what they are and how they differ, we're going to look at, because they are the two most used models, the two most used mechanisms in order to create AI-generated images. And what they really are is what we're going to look at next. Let's start with GANs, Generative Adversarial Networks. In essence, the way I would describe it and the way I used AI in order to create this image, for instance, is I would say GANs are like a discussion between two people. One person is an artist, the other person is an art critic. And the artist tries to paint a painting and tries to convey convince the art critic that the painting is not a fake, it is a real painting from a certain painter. So for instance, let's say the artist paints the Mona Lisa and tells the critic, hey, this is the real Mona Lisa. The critic, based on their training, will then say, no, that is not the Mona Lisa, I know that's a fake. Or based on their training, they might say, yeah, I believe you, right? That looks like the Mona Lisa, brush strokes, color palette, everything looks identical. That is the Mona Lisa. So you can see this is a back and forth between the artist, who then, if the critic says they don't believe, will take the painting, recreate it, create a new one, apply some changes, try again, and the critic will respond and say, yeah, yes or no, I believe that this is the real Mona Lisa or not. And by the way, all the images that you see on my slides, unless they have a caption on it, they're all AI generated, so including this one, where I said, or I told the AI, I would like an artist and a critic discuss about various versions of a Mona Lisa in the background. So we call in GANs, we call these two people, not the painter and the critic, we call them generator and discriminator. The generator is the artist who tries to convincingly fake a certain topic, a certain image. The discriminator, the critic, tells, yes, this is a real image or this is a fake image. And that goes back and forth. Well, back and forth for how long, right? They can't go on forever. Well, technically they could if we have the time, but who wants to wait forever? It's a learning process, right? It's a cat and mouse game where the generator improves the fakes in every iteration, where the discriminator improves at spotting fakes to their learning. And that cat and mouse game that just goes on and on until a certain endpoint is reached. And that endpoint can be, dictated by various different parameters. What we do have is a feedback loop, which is the discriminator, the critic, gives the generator a score. And that score is then used by the generator to make changes. That score is not going to tell the artist what to change, right? It's just going to be a score that says, hey, you are 5 points off on a whatever scale they're using. You are 10 points off. You're 100 points off from me believing that this is real. And then the generator will apply changes based on their rule set, based on their parameters, trying to minimize the difference in that score and trying to achieve what's called convergence. Convergence is achieved when enough steps have been gone through, the generator has gone better and better until the discriminator, in our case the art critic, can no longer distinguish it from being the real painting. Until then, and the critic says, yes, I believe that is the real Mona Lisa, you have now achieved convergence. And that is when we receive the images, right? When we run these AI image generators, online or local, when we receive the image, that is the image that has achieved convergence. That's the image that we get. We can prematurely look at images too, right? And we'll look at that later on too. Of course, when we run this local and we debug through it and we check in intermediate steps, we can exactly see how images evolve and how these images come together. But these intermediate steps, they are not of interest for 99% of the users. 99% of the users want to see the outcome, want to see the final result. And in order to achieve convergence, we have to look at objective measurement. We have to look at mathematical models that look at the images, that look at the distances that the images have from the reality, and reality being the training data, and that govern these adjustments. Of course, there's always also human intervention optional, which means human intervention is something where if the model does something that we absolutely disagree with, we can go in, we can remove artifacts, we can overwrite some weights, we can verify final results and apply our own weights to something that the scoring system has done for us. So human intervention is always a possibility to do as well. Now, in opposition to the GANs, we have VAEs, Variational Autoencoders, and they work a little different. They are more orderly, they are more structured. It's more like a skilled artist who learns and studies forever from real images and looks very, very closely at all the individual meta information they can pull from all these images, all these paintings, in order to then create a recipe and a blueprint for batch generation of images just like the ones that they have looked at. There is no art critic that tells them, hey, yeah, you're on the right track, but you're a little off. Make it new one, adjust it, here's a score. No, there's all the training is done beforehand, very extensively, and only after all the training has been done, no minimal corrections here or there, just all the training is done, then it spits out this blueprint or this recipe, and that contains, information about style, about patterns, about features, brushes, color palettes, all different kinds of things that it learned from the image set it was looking at, and then it can create images based on that. So it's more for very specific images rather than general images, right? GANs are more like generating something in general without any specificity to certain certain topics or whatever. VAEs are very specific. You say, I would like to generate faces. I would like to generate textures for wallpapers. I would like to generate whatever. And it learns all the characteristics for this topic in order to create this blueprint or this recipe. I used auto-generated AI service to create this image here, for instance. I wasn't sure how I would tell it what I want, right? I wanted to say, hey, if you were an artist and you were going to explain to someone what VAEs are, but you want to do it in picture form, how would you do it, right? And I wasn't sure how to create this prompt, so I was going into actually a GPT service, asking it to make a prompt for me, and then I used that prompt to create this image that you can see here, where a painter has studied many different versions of whatever they're trying to paint, whatever they're trying to create or sculpture, and then they create a batch of many iterations with minimal differences of that blueprint, of that recipe, where the user, us, can then say, okay, we like this direction, we like this direction, we like not this direction, and based on whatever we deem good, these parameter sets are then scored higher than other parameter sets that were omitted or not taken. For instance, what's very common in the use scenario for VAEs is human faces, because it's very simple to design and reflect characteristics as meta information for VAEs, right? You can have skin color. The color palette is not as broad as a general create whatever image, right? It's typically skin tone type of colors. There is very specific parameters that make up a face. There is eyes, there is eye distance, there is eyelids, there is lips, lip colors, there is nose sizes. There's very distinct textures for skin that can all be put into these parameters that VAE can look at and create a recipe for. Therefore, these image generations of that type are very common to use VAEs. But another thing that might, some people might not initially or immediately realize is a lot of these AI services that you can use online that allow you to create images, they're not based on GANs or VAs. Most of them, I'm not sure, but I would say if it was an educated guess to make all of them use both at this point, because you can benefit from both approaches to create images, and some of them actually have to use both in order to produce the best results. So for instance, some of these services allow you to create an image of a certain resolution, let's say 720 by 540, and it creates something and you like it, and then you say, okay, I would like to have this bigger and extend it. I would like to extend this out to 1080, 1080 by 1080 maybe, right? A very big one. That is a prime example where you start out using a GAN to create the image, but then continue and use a VAE to learn characteristics of this image, because the extension of this image, the outsides, the border and whatever has not been filled in that you want filled in, is not something that you would create from scratch, right? This is something where you're not just starting from random noise and with a generator and discriminator go back and forth whether it's good or not. No, you want to have discrete metrics. You want to have information about what is this image composed of already, and how do I use this information to extend my image on the edges, up, down, and left and right. There's a question given the same input, do they generate the same output? A real artist would probably create something slightly different. No, they will create something different. Both of them, GANs and VAEs, will always create something different. It will never be exactly the same. Especially with VAEs, as we've seen, we create batches, right? We're creating a recipe or a blueprint, and we usually run this in batches. We don't create just one. We create whatever we say, however many we want, in order to then nail down certain recipes that we like and certain recipes that we don't like. But ultimately, it's always going to be something different. Now, if we are very, very strict, right? Very, very strict about image generation, and we start out with the same base image, especially for GANs, where we usually start out with noise, and we follow the same instruction, technically, yes. Ultimately, it's still going to be recreatable with the same seed, with the same algorithmic. You will be able to create the same image again, but that is not the point of AI image generation, right? The point is that it learns what is good, that it omits what is bad, and gives the user, us as humans, a choice of what we think is good, because it cannot decide what looks good and what looks bad, right? It needs feedback from us to tell it, yeah, we like this, we don't like that, and it might make an image where you say, yeah, it might say, this looks like a giraffe, that looks really good, but we, say, no, well, I've seen what a giraffe looks like. It has a lot, taller neck, for instance. It's not a good giraffe, so make a change, make it taller. So it needs that feedback in order to learn what actually is good, what isn't good. Do tools like Midjourney use a combination of these two? Yes, right? It's almost always a combination of not just these two, there's others even involved, other algorithms, because one of them alone would not provide them with the capability and creating auto and photorealistic images as we are able to see them and create them today with stuff like DALL-E, Midjourney, and Alchemy, for instance. They never just use one, right? And they're not new either. VAEs, the research paper is from 2013. GANs, the main research paper is from 2014. Notable AI products that started out using them, but you can see that, most of these aren't just exclusively using them. They're also using or making use of other models. So these are not, first of all, they're not new, and they're not exclusive to certain applications. So it's always a combination that either run in succession or in parallel to achieve certain things. And if you think about, what are certain models and certain approaches good at, of course, they're going to leverage that to provide that sort of service. So what do we need to consider in order to create such a generative model, right? We have to, of course, first look at the environment and prepare data. We have to have an environment set up. We have certain software that allows us to run this. There's PyTorch, there's TensorFlow, there's different frameworks that allow us to run this locally or publish it to a server architecture. We have to look at the hardware. We probably need some beefy GPU or a combination of multiple GPUs in order to run this in acceptable time. We have to look at data collection. We have to say, okay, what is the quality of the data set and how do we organize the data set? We have to probably go through the data set and omit things that we deem low quality, right? We do not want to train our models on data sets that are of low quality. We also need to look at pre-processing. One of the key features of almost all of the models is that the images you generate are best if they have the same dimension as the images the model was trained on. If you don't, you a lot of times get various artifacts in it. So there's this double head phenomenon, for instance, if you create anything that has humanoid shape or also sometimes animals, and you get this double head exposure on images, especially if you change the sizing of something. There is always, or it should always go with the model size whenever you create something, because that guarantees you the best outcome. We also need to augment our data sets with meta information. So it's not when we train something that we, in these models, just throw a bunch of images in it and that's it. There's a lot of meta information in these images that we have to consider, where we For instance, we'll see that in one of my next slides where we have associated information to images to certain terms when we run a text to image prompt that allows the model to say, you know what, I know what we'll see that what a rhino is, what attributes that has because of the meta information I was trained on. But only if it was trained on that kind of stuff, it will be able to make these conclusions. When training for image generation, we also have to consider certain things. We have to, for instance, look at the model architecture. We have to say, is our model, again, is it a VAE? Are we including diffusion? Is it more than one? Is it a combination of all? Does it depend on what the user wants? Because, like I said before, these models are good at very specific things, but not good at other things, right? So if I say, let's take this image here, for instance. I said to an AI, as I used Leonardo for this, give me an image, AI versus AI. And that's it, right? I didn't specify how I want AI versus AI, and it decided to give me this image. If I now said, all right, I like this image, but I would like to extend it, right? I don't see the legs of these two robots, for instance, right? So there's two completely different approaches in order to create this, because in order to create this image, it needs something like a GAN, where we start out from nothing and create something that is acceptable based on the prompt we've given it, right? And once it has created something where the critic says, all right, good, you can use that, it's going to be believable to the user, to us, that this is AI versus AI, let's deliver it. That is a completely different approach than to say, now take the image as is, with its features, with its lighting, with its characteristics, and extend it downwards so we can see the legs of these two robots, right? That's a completely different approach. And for that part, the extension VAEs are much better, right? Because they can look at the existing image, can extract these information, this metadata, and then use that in order to generate a recipe in order to, give us hundreds and hundreds of versions of it. Then quantitative and qualitative assessment will eliminate a lot of them, will rectify some of the issues that are in there, and give us however many we want, right? Usually it gives you like the option to say, I want 1 image, 2 images, 4 images, 6 images, 8, whatever, right? So the best from the batch that we want will be presented to us. Now, the training procedure that we go through, right, with training a model has to be, of course, long enough in order to create good images, right? If we give it 2 or 3 images to learn from, it's not going to be very good. But at the same time, we have to be also mindful that, yes, we can overtrain. It's also called overfitting. So if you train too much, then you can also create images that start to be worse than if you trained with half of the amount of training data that you had. Very good example for that is, for instance, you say, here's a data set, here is 10 million images. Learn from this data set everything you can. The model says, okay, fine, I'm going to learn this, I'm going to extract all the information I can. And then you say, all right, I'm going to run another epoch, and an epoch is is a term for running through the whole data set again on a more granular level and learn more about it. Then the model says, okay, fine, I'm going to get better, I'm going to learn more about it, and I'm going to do it again and again and again until it says, all right, I know everything, I can learn from it. And you also used to say, you know what, run it another 10 times, I want you to be even better. And then the model starts to look at granular level things that it's not supposed to look at. For instance, there are blemishes, there is noise, there are artifacts in certain digital images, in almost all of them in some degree there is, and it starts to pick those up. You say, okay, there is an artifact in every 100th or every 1000th image is an artifact because the camera it was shot at has a little lens flare at the top or a little glare at the bottom, but it's not something that's supposed to be there, and that was omitted during training because it wasn't significant. If it has learned everything else, though, it will learn all these blemishes and artifacts as well, and suddenly your model is trained on recreating these artifacts, is trained on recreating these blemishes, which you initially did not have. So yes, you can completely overtrain something as well and ruin your model that you have created by overfitting it. There are certain parameters, of course, that influence the model's outcome, and everybody who has used these services online will know, depending on what service you use, there's a lot, if you click the advanced tab, a lot different parameters that you can set, that you can look at. There are certain hyperparameters that, for instance, dictate the learning rate, the step size to adjust weights. If you say, hey, I'm adjusting my weights after every step, after every 5 steps, however many you want, you can say, what's the batch size? How many are we going to create through every iteration, especially in VAEs? Of course, most of these parameters will have a direct impact on how fast or how slow something is running. The number of epochs, how many times is it going to run or traverse entirely through the training data to learn certain things. There is regularization parameters. Certain parameters actively prevent overfitting or underfitting, right? Noise removal, for instance. You can have artifact removal, that sort of stuff. There are a lot of parameters for different loss functions that can be implemented. Loss functions is something that also has been around for a very long time. These are the functions that influence the type and quality of the generated images. They measure, for instance, how well a prediction of a certain model aligns with the truth, and the truth being the training data. And these functions that it tries to use to align the generated images with the truth, with the training data, there is a lot of different. There is a hinge loss function, there is cross entropy loss function, mean squared error. I mean, these mathematical models for these comparison and distinguishing functionalities, they have been around for a very long time as well, right? They're not something new. It's just there's different approaches to use certain ones in certain scenarios to weigh them differently and give them parameters. And a lot of these parameters are auto-generated by the models, by the organization that runs the models, but some of them are, of course, exposed to the user to let the user actively influence them. And if you run it locally, well, then you have, I mean, if you run it locally, not just run it locally, but compile it locally, you have access to all of these parameters. So it gives you even more power. You have to really deep dive into this, though, in order to change those parameters, because you can very easily ruin your entire setup by making changes that you're not familiar with. You just play around with this and without knowing exactly and on a mathematical background what you're actually doing, you can completely ruin your setup with this. And yeah, I've done this. I'm going to show a slide where I'm running this locally as well. But it can get very granular where you really have to know what you're doing in order to make any use out of changing these parameters. Of course, we have to look at optimization algorithms and algorithm optimization, right? It's two different things. We have optimization algorithms, also not new, right? Optimization algorithms have been around for decades. There's a gradient descent algorithms, stochastic gradient descent algorithms, LBGFS algorithms. They have, lots and lots, tens and tens years of research on them, and the industry knows what they are. It's just the new and the exciting thing about them is now we have the capability to actually optimize them, right? It's not just that these are optimization algorithms. We have the ability now to optimize optimization algorithms because we have the power in hardware, in data centers, to do something that previously wasn't able, or we weren't able to do. So now we can play around with these and provide these parameters also to some degree to the user to let the user directly influence the optimization algorithms and say, you know what, if we change this, the user can play around. They have to give them some fancy names, right? They're not always the same names as the mathematical model has, because most average user on the internet is not going to be able to know what to do with this. So they give them some fancy names, and typically they all have a slightly different name when you look at the different UIs of the different services that are offered. But yeah, you can influence these algorithms with parameters too if they are exposed to the user. And we also have parameters when we explore the latent space, and that is also something that is still explored heavily, looked at heavily, because it allows us to further optimize what we're doing. What exploration of latent space means, and here's another depiction how AI would depict it if I were to ask it, or I did ask it. You have a model, you have something depicted in a high level of complexity, right? Very high level complexity that has a lot of parameters, and you say, I want to make changes to this and rerun it, but in order to make changes to it, it takes for the model a long time to apply those changes and recompute it. So what I'm going to do is I'm going to map something from a higher level onto some lower level, make the changes on the lower level, apply those changes on the lower level, and then upscale it back to a higher degree of complexity in order to get my result. And in certain applications, especially image generation, this is something, when we optimize these algorithms, can be a lot faster by downscaling and upscaling. And while downscaled, making these changes, making these parameter changes, than doing it all on the maximum scale level model. So this is also something that also allows us to further increase the usability of these algorithms, because we just go from high complexity environments into something that's very low complexity and something that has multi-dimensional vectors. We translate that something in lower dimensional vectors, make the changes, and then upscale it back into a higher complexity level. So now let's put this all together, right? Let's say, okay, now if we type in some text and we say, hey, we would like to create a rhino, for instance, how does it know? Well, how does it know what a rhino looks like? It might have been trained on some images for rhinos, but maybe not. And is it still able to create a rhino if it never has seen a rhino? And the answer is yes, right? It depends on the training. There are options that it can create something that it has never seen based just on the model that it has looked at, based on the meta information that's part of the model. There is, for instance, some pre-trained text embeddings, the text-to-vector embeddings. You can see a simple illustration of it on the right side, where you have certain words associated very closely to one another. It's a two-dimensional, sometimes three-dimensional space, where you say, okay, you know what, if we have a rhino, it has certain characteristics, like it's probably gray, it probably has 4 thick legs, it has 1 or 2 horns, it has a short tail, it has a very specific skin texture, and it has specific postures it stands in, right? It can't stand on 2 legs, for instance. So all this information is composed as meta information in these text embeddings, right? And you can see if something, let's say our rhino is somewhere, if we have an animal text embedding, for instance, let's say our rhino is up here in that blue area on the top side of this vector graphic, then any picture or any point that is also blue around it is somehow closely related to the rhino. And the closer it is to the word rhino, the more importance it has. And so when we ask or write a prompt, hey, I would like a rhino, it not only knows what a rhino is based on the images that it has been trained on, it also knows based on the meta information from these text embeddings that, hey, whatever I'm creating, I need to make sure I have 4 thick legs. I need to have a horn, at least 1, probably a short tail. If it's from the front, I don't see it, but if it's from the side or from the back, the tail is probably short. It has a certain skin texture I need to create and a certain color I need to use. I can't just make the rhino red unless the user asks for it, right? But this kind of stuff is all meta information that is used. And now, even if that model has never seen the image of a rhino, like it's been trained on all animals, but not a rhino ever, but it has text embedding vector graphics like this, where all the images are accompanied with information about it, it will still be able to create something. It might not create something that we would say, yeah, that's a rhino, that's photorealistic, but it will say, okay, we have to create an animal that stands on 4 thick legs. We'll make it gray, give it a certain texture, and it's going to have a horn. So whether it's going to be for us looking like a unicorn or a rhino, well, different question, but it will still be able to create something somehow reflecting a rhino at least. And then if we run this locally, right, we can go through the process and say, okay, where do we start? Where do we end? How many steps do we have? How does this image develop? And typically when we start at step 0, we start with just some random noise, right? And it really doesn't matter what that noise is. It can be absolutely random, like just a random multicolor something that doesn't reflect anything, but based on additional steps that we go through, every iteration will closer resemble what we want. And if we go through the steps here and say, hey, step 5, art critic, is this a rhino? The art critic will say, oh, no, that's not a rhino. Step 10, the art critic will say, no, that's still not a rhino. Step 20, the art critic will say, you know what, that could be a rhino, there could be something else too, I'm not so sure yet, right? This could be a hippo, could be a rhino, I'm not so sure. Let's go, let's continue, I'm not 100% certain yet. Then step 40, the art critic or the discriminator in the model, right, says, you know what, it kind of looks like a rhino. We still have a little problem here because, we have a horn where an ear should be, so we have to make sure, based on the meta information, I know it has 2 ears. This is, a horn instead of an ear. And the color in the front doesn't fit, right? It's not supposed to be orange on the horn. So let's continue. And then at step 80, it says, you know what? That looks really good. We're almost there. We just have to look a little bit on the texture, right? The skin texture isn't just right yet, but let's do a little bit more. And then at step 150, it says, okay, fine, that's a rhino. Like, I believe this is a real rhino. I'm done discriminating your work. Artist, you're done. Like that's good job. And so yeah, when you run this, I mean, it depends on what setup you have and how powerful of a model you can run. I have a machine that I used for this that's, I wouldn't say it's super old, but just to give you a little bit of an idea, it's about a 5-year-old, back then, high-performant A5 CPU. It has used a 2 GB model, pre-trained model for it. I have a GTX 1070 in it. And to run this in Python, it took somewhere between 2 and 10 minutes, depending on the amount of steps or how many steps I wanted to run it through. And that allowed me to create images based on prompts. Now, of course, these models, these 2 GB models, are nowhere near as powerful as what Midjourney can do, right? Or what DALL-E can do, or what Leonardo can do. So we're talking here on a level, I always compare it to, this is what a child in kindergarten could draw if you tell it to, and then you give it the prompt, right? So on that level, kind of. But yeah, you can run this. The setup is also a different story. I'm going to go into that a little bit as well. But if we run this, here's my example results that I created on my machine. I said I want a blue car in the moon, and I always wanted 6 images. So it gave me 6 images, right? So some of them, yeah, first one is just nothing. Second, third, and fourth one is cars, right? They're blue cars, maybe on the texture of a moon, not really. And the last 2 images, again, can't really say what that is. If I say I want a red flower on a ship, I get some red flowers, sure. I'm not sure I can identify a ship there. Maybe it doesn't know what a ship is. Maybe that model, that 2 GB model, wasn't trained on what a ship is. So it tried to do something with it, but that's a bit it can come up with. If I said kangaroo on a mountain, from that model that I used, I suppose that's the best outcome from the prompts I tried. You can tell it's a kangaroo, except for maybe image 3. Doesn't necessarily resemble a kangaroo, but it's on a mountain, so there's that. The texture on the last image, not too bad, right? The sandy, rocky surface and so on. So it is able to put together what I want. Obviously, nowhere near what we're looking at if we look at what Midjourney, DALL-E, Leonardo, and all these platforms can do on a virtually unlimited power resource behind them. Now, the advantage, however, by running this locally is if you run this, and you not just run this, but you compile this on your computer, you have access to every single iteration and every single step of it. And you can pause it, and you can even output intermediate images, and you can actually create yourself, a chart of how your image that you create comes together. And with the step reduction, we can look at, right, this image, the one that after 50 steps produced this, came from that, right? And you don't necessarily always see whatever you start out with, even a close resemblance of what you end up with, right? A lot of times these images drastically change from the first 5 to 10 steps to the final steps that you get, because sometimes the discriminator says, such a big difference in score that it gives the generator, that the generator says, you know what, I'm on the completely wrong path. I need to do an almost U-turn to go different set of parameters, different scale of parameters in order to actually achieve what the prompt wanted me to achieve, and it has to completely deviate from the route it's going towards. We always, however, whenever we start something, we start, like I said before, with an initial noise. We have a random noise image, and that image we gradually try to improve, and different algorithms do it differently, right? Different algorithms try to reduce the image, remove all the noise from it, generate more and more believable images that resemble something the art critic would approve of, and ultimately end up with a generated image that in the end is presentable. Now, somewhere on the highest level of image generation, not only depends on the model and the platform it runs on, it highly depends on how good you are in telling the model what you want. So for instance, you can talk about prompt engineering and say, on the left side, I used Leonardo AI for this, for instance, and say, I would like an astronaut cat playing the piano in space with a black hole in the background, and I gave it additional parameters: high quality, 4K render, dramatic light, photoreal, detailed POV shot, volumetric lighting, and golden hour. All of these additional parameters give the model something to work with, versus if I just use what I want without additional parameters, same model, same platform, I get the image on the right, which obviously isn't bad, right? But you can see there is a drastic difference already by using the same model and the same prompt just by adding additional prompts in order to create what I want and influence the outcome by giving it some more information, some more detail. And a common misconception is that the more you give, the more it deviates from what you actually want. It's quite the opposite, right? The more detailed you are, the longer the prompt is, the more detailed you are, the more likely you're getting what you want. It's counterintuitive a little bit, because if I'm with an artist and I give the artist a list of this long of a list of prompts what I want the artist to make for me, I can assume, okay, the artist is not going to take everything into consideration. It's going to forget something. It's going to overlook something. But models don't, right? They take into consideration everything. And therefore, it's always better to give as much info, as much detail as possible. There's another question, that we have many AI-generated models of people include more than 5 fingers per hand. Was this due to a lack of information in the metadata? Yeah, this is one of the biggest drawbacks in AI-generated images, is extremities, is fingers, feet, toes, that sort of stuff. It not necessarily is the lack of information in the metadata, because it knows, okay, a human should have 5 fingers, right? A human should have 5 toes. A human should have 2 feet. The problem really is that it looks drastically different if you take a car and you turn the car slightly to the left. It doesn't look drastically different, right? If you have a hand and you turn the hand slightly to the right, it looks drastically different. You don't see certain fingers. If you turn it the other way, the front, it looks completely different. And then think about, all right, it needs to have it needs to hold something. You have to wrap your hand around something, maybe a bat from a baseball or something, right? That makes it, again, part of the hand invisible, because it's behind the bed, so it has to know what does it look like where it appears again. So fingers are one of the most difficult part of AIs to generate, and a lot of times when you have these super ultra high realistic images of certain celebrities, famous people, and so on, the first thing you look at are extremities. You look at the hands, you look at, is this a realistic hand or not? Because that is probably the first giveaway that something isn't real, if you look at the hands or feet, if they have them. So that is, yeah, this is one of the biggest problems. Now, with prompt engineering, it also not just depends on how detailed you are, but of course it depends on what model you're running on. So we have, for instance, let's do a comparison with one prompt, a dynamic action scene of a knight battling a dragon on a cliffside with roaring waves below, inspired by the Romanticism movement, reminiscent of the works of Eugene Delacroix. So very complex prompt, a prompt that outlines what I want, what the details are, and it also assumes the model has been trained on Romanticism and it has been trained on Eugene Delacroix, because if it hasn't, it wouldn't know who that is, and wouldn't know how to take that into consideration. And we can clearly see how these models are different from one another. There's all of these models that I used. I have not changed any settings. I use default parameters for everything to make it as comparable as possible. Midjourney and Leonardo, by far the best result that we have gotten here. They take into consideration the brushes, the brush strokes, the color palette for Romanticism, and especially Eugene Delacroix. You can tell they know who that person was, and that they were trained on that specific artist. Night Cafe does an okay job, I suppose. There's a dragon, there is a knight, they're fighting. Adobe Firefly goes a little different route, right? Not such a realistic depiction of the knight that's there. And then I asked a friend of mine who has Dreamshaper 8 installed locally, which is a powerful image generation model that they can run locally. I gave that friend the same prompt. They ran it, and that is the image that they came up with. Dreamshaper 8 said, yeah, here's a knight, here's a cliffside, here's some waves, but you know what? You don't get a dragon, you get a horse with a dragon tail instead. So it just shows there's certain things that the model obviously doesn't know about. It doesn't know about Romanticism, it doesn't know about Eugene Delacroix, but even with the prompt it was given, it probably had a higher association with a knight and a horse than a knight and a dragon, based on the model that was trained on. There were probably more images with knights and horses, and whatever text-to-vector mapping it was using probably had meta information on there that says a knight must have a horse. That was probably weighed higher than the initial prompt that, hey, a knight is fighting a dragon. And then when it says, when the art critic says, you know what, there is no dragon in this picture, and it says, okay, fine, here's a tail of a dragon on the horse. Are you happy now? And the art critic either said, yes, I'm happy, or we ran out of iterations that were determined by the user. Eventually, we got this image. So you don't have to run this local though, right? If you don't have a machine that's strong enough to do this kind of stuff, there's a lot of different ways how you can run this. For instance, on RunPod, you can set this up. You can rent this kind of hardware. You can say what kind of hardware you want. And a lot of the models are already preloaded there. You can just pick them. And you just pay by usage, right? You pay a little bit for idling, but most of the time you just then really pay for the usage, the amount of time you actually use it and run it. And the biggest difference, right, is you can get going in minutes using this versus setting it up locally on your own. By giving you a comparison, you can set this up, a RunPod, in 5 to 10 minutes and already run some prompts versus installing, compiling, downloading, and running the simple 2 GB model that I had that was running in a Python script. Took me over 5 hours to get that working, right? So there's a lot of time saving that you have if you decide to do that, and it's not that expensive, right? I mean, it depends on the hardware that you use. It's several bucks an hour that you can pay, or just a few cents an hour, depending on the size of the GPU that you would like to rent there. And then, of course, depending on what you run and what model you run and what UI you put on top of this, you have either a lot or few settings that you can play around with. You either have a lot or few parameters you are exposed to that you can use to influence the images that are generated from this image or from the prompt that you provide. And if you want to run this local, or if you want to run this online in a RunPod, for instance, like I said, you either have these pre-configured, pre-installed models that you can use there, or you can get your own. You probably have heard of Hugging Face. It's this site where all these creators come together with different models for different purposes, very specific models, more general models that people make available for other people to use, for other people to play around with, and of course also to compare and benchmark, right? Everybody in this industry is always about benchmarking too, making sure, hey, whatever you're doing, I'm doing it better than somebody else, because why else would anybody use what I'm trying to use or trying to sell? So of course, with all these models on Hugging Face, there's certain ones that are rated very high, certain ones that are rated very low, certain ones for very specific applications. So if you're interested in looking around, go on to Hugging Face and check this out yourself. All right, we're nearing the end of our hour. Hope that was a overview. Most people had something to take away from, something that they didn't know, something they learned, something that made them enthusiastic about looking into the self. Maybe try this out if you haven't. There's a lot, like I said, there's a lot of different services online that you can use. You can sign up. Most of those services allow you to use and play around with them for free up to a certain point. Midjourney gives you some credits. Leonardo gives you some credits and replenish them every day. So you can keep using that for free unless you want to go beyond what your daily limit is, that sort of stuff. Or try it out yourself and install it locally, right? There's a lot of resources on Hugging Face, how to download the models and how to install and then run them, or use them on a pre-configured, pre-installed online platform like RunPod. All right, couple other announcements. I already talked about this in the beginning. We have the AI consulting services and the executive briefings here at Code Consulting that we offer. If you're interested, codemac.com/AI and codemac.com/executive briefing. Code staffing, gone over that as well. Here's the link again, codestaffing.com, if you would like to be part of the Code Staffing initiative and of our operation. Upcoming code training classes, codemac.com/training. We have public AI training classes coming up. We, of course, also provide individualized and private classes, lessons, trainings, and mentoring sessions for organizations and or companies. So reach out to us if you have need for that. We have the 2 upcoming events from us. We have our State of .NET about .NET 8 in November. We have our Code Presents coming up with the local LLM running later in October. The slide deck and the recording of this session will be made available, of course, online, codemac.com/codepresents. From our other events, they're online as well if they are from the state-of.net webinar series, codemac.com/stateof.net. All our resources are available there. Would be happy if you were to subscribe to our channel, youtube.com/codemac. All our sessions are recorded. All our sessions are available after the fact on YouTube as well. So everybody who misses one of these events can still check them out later on YouTube, of course. Another reminder, do the survey, win the $100 Amazon gift card. Try out if that QR code works for you, the AI generated one, or if your phone or your camera, whichever you're using, is relying still on the old school QR code, so to say. It depends. Like I said, I had one phone I tried that it worked with, the other one it didn't. So I guess it just depends. And that's it. Let's see if we have any other questions. Or if there is anything else. If there are any questions later on, you are more than welcome to, of course, send them through email. You will certainly get an answer. You can also talk to us on our YouTube channel. And if you post questions there, chances are you might also get an answer there. Thanks, everyone, for joining. Have a wonderful rest of your day, and see you again on the next Code Presents. See you next time.